A very good day. Today we'll be presenting our project which is titled Grinding Wheel Monitoring. We are from group 5. So let me introduce myself first. I'm Shalini N. My other group members which are Calvinson Anna Thompson, Nazirul Ikhwan, Nora Afrika and Siti Nur Shafika.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nura Afika. Today I want to present my project, which is I will present this slide about executive summary. This slide shows the executive summary of our project. Our project focus on monitoring grinding wheel wear in real time. By monitoring the wheel condition while the machine is running, we can reduce machine downtime. This help improve manufacturing efficiency and reduce maintenance costs. At the same time, it can extend the lifespan the grinding wheel. Overall, this system help the manufacturing process become more efficient and cost effective. That's all I will to present about next slide. Next, I will to present about project objective. This slide show the objective of our project. The first objective is real-time monitoring. This means the system can check the grinding wheel condition while the machine is running. The second objective is cost reductions. When we know the wheel condition early, we can avoid machine breakdown and reduce maintenance costs. And the third objective is to extend the lifespan of the grinding wheel. By monitoring wear, the wheel can be used safely for a long time. Overall, this project helped to improve efficiency, reduce costs, and increase tool life in manufacturing. That's all. I will present the next slide. Next, I will present about problem statement. This slide explains about problem statement of our project. Currently, grinding wheel inspection is done manually. This process takes time and depends heavily on operator experience. Because there is no real-time monitoring, wheel wear is often not noticed early. This can cause poor grinding quality and unexpected machine downtime. As a result, grinding wheels are sometimes replaced too early or too late, which increase maintenance costs and reduce efficiency. Therefore, there is a need for a real-time grinding wheel monitoring system to detect wear early and improve overall manufacturing performance. That is all. I will to move to the next slide to present. For the last part of my present is project scope and location overview. This slide shows the project scope and location. This project focuses on automotive and manufacturing industry that use grinding wheels. We developed a sensor-based system to monitor grinding wheel wear in real time. The system is implemented and tested at a manufacturing facility in Penang. The main purpose is to reduce machine downtime, maintenance costs, and grinding wheel waste. The target industry are automotive and grinding related to industry. That's all of my part for the presentation. I will pass for the next person. Thank you.
My name is Siti Nur Shafika binti Rahim and I'm going to present about project schedule, risk assessment and mitigation taken during the projects. Okay, from this slide, this is our project Gantt chart, which is we use to plan and manage the project schedule over a total duration of 15 weeks. And this Gantt chart really help us clearly see the sequence activities during the projects, the duration of each task, and how different tasks are related to one another. And the project begins with project planning, where the objective, scope, and overall approach of the project are defined. This is followed by system concept design, which is focused on determine how the grinding wheel wear monitoring system will function. Next, sensor selection and procurement is carried out to ensure suitable sensor and component are available before system development begins. Once the components are ready, hardware setup and installation is performed, followed by data acquisition system development to allow data to be collected during the grinding operations. And after that, signal processing and wear detection logic are developed to analyze the sensor data and identify grinding wheel wear. And at the final stage, system testing, validation, and documentation are completed. From this Gantt chart, we really help us to ensure that the project is well organized, progress smoothly, and is completed within the planned time frame. Okay, for this slide, I'm going to present about the project milestone, which is important for us to check and to measure the progress of the projects. Each milestone represents the completion of major stage and help ensure that the project always stay on track. The first milestone is the completion of project planning in week 1, where the project goals, schedule, and responsibility are clearly defined. And the second milestone is the finalization of system concept design in week 2, which confirm the technical direction of the projects. And by the week 4, the third milestone is achieved with the procurement and availability of sensor and component, which allow the project to move into the development phase. And for the next milestone involve the completion of hardware installation and data acquisition setup, ensuring that the system is physically ready for operation before the implementation of wear and detection and signal processing logic take place. And for the final milestone are the completion of system testing and validations and the submission of the final report in week 15. From this milestone help us monitor uh, the time the time taken and to ensure that the project complete within the times planning. This slide explains the potential risks involved in the project and the strategy used to reduce their impact. This assessment is crucial to ensure that the project can be completed safely, accurately, and on time. First, there are technical risks such as sensor failure or incorrect data readings. And when this happens, the wear data may not be accurate. To reduce this risk, the sensors are properly tested and calibrated before use, and backup sensors are prepared if needed. Next, there are system and data risks where error may occur during data collections. This is controlled by testing the system early and saving data regularly to prevent data loss. There are also schedule risks, mainly caused by delays in purchasing components, and this is managed by planning early and using available laboratory equipment if needed. For financial risks, such as budget overrun and careful planning, is done to ensure costs remain within the allocated budgets. Existing laboratory equipment is also reused to reduce extra expenses. In terms of safety risks, injuries may occur during grinding operations, and to prevent this, all safety rules are followed and personal protective equipment is worn and experiments are carried out under supervision. Lastly, quality risks such as incomplete testing are controlled by performing multiple test runs and reviewing the results with a supervisor.
Okay, my name is Calvinson Anak Thompson, and this section present the engineering economic analysis of the purpose system. It evaluate the project final feasibility to cost elimination, cash flow analysis, payback period, break even analysis, and last but not least is internal rate of return. For this slide, it explains the purpose of engineering economic analysis. The main objective is to evaluate the financial feasibility of the proposed system, justify the RM 5000, get investment using engineering economics tool, and support management decision making. The analysis is carried out through cost elimination, cash flow analysis, and payback decision or period evaluation following the shown on the right. This slide presents the cost estimation of the purpose system. The total project cost is RM 5000, which is divided into direct costs and indirect costs. This breakdown help ensure the expense related to system development implementation are properly accounted for. This slide shows the cost estimation for the purpose system. Cost estimation is important to ensure the project stay within budget, identify major cost driver, and support investment decision. The total project cost is RM 5000, which is divided into direct costs and indirect costs. Most of the costs allocated to system development, including sensor, equipment, and software. This section presents the cash flow and financial analysis for the purpose system. It examines how the initial investment recover over time form of the basis for evaluating payback period, break-even point, and internal rate of return. For this slide, present the cash flow assumption used for financial analysis. The project require investment of 5,000 at the year zero, and it's evaluated over a 5-year period. The system generates a constant annual net cash inflow of 50,000, representing operational gearing. At the end of 5 years, a salvage value of 5,000 is considered. A minimum attractive rate of return is 10% is used for financial evaluation. This slide shows the cash flow analysis for the purpose system. An initial investment of 50,000 is required at year zero. The project is evaluated over a 5-year period and generate a constant annual net cash inflow of 15,000. A salvage value of 5,000 is considered at the end of year 5, and a minimum attractive rate of return is 10% is applied. Based of Based on this assumption, the present net worth is positive, indicating that the project is financially acceptable. This slide continues the cash flow analysis using annual worth and future worth. Based on the same cash flow assumption, the annual worth is positive, which indicates the project generates consistent annual profitability over its service life. In addition, the future worth is also positive, showing the project has a positive value at the end of the project life. Overall, this result further support the financial acceptability of the proposed system. This slide introduces the payback period analysis, which evaluates how long it takes for the project to recover its initial investment. And I will now explain the payback period result. The payback period is defined as the time required to recover the initial investment. For this project, the payback period is calculated using the initial investment divided by annual cash inflow. Based on the initial investment of 5,000 and annual cash inflow of 15,000, the payback period is 3.33 years, meaning that investment is recovered slightly after the third year. Based on the payback period analysis, this project recover the initial investment of 5,000 slightly after a third year of operation, with the payback period of approximately 3.33 years. This recovery period considered acceptable for industrial monitoring and automation project, indicating that the proposed system is financially feasible. The break-even analysis, which determines the minimum number of units that must be sold for the project to recover its total fixed cost. The analysis is based on a fixed cost of 5,000, a selling price of 10,000 per unit, and variable cost of 3,000 per unit. Based on this assumption, the project reached its break-even point at approximately 8 units sold, meaning total revenue equal total cost, and the project make neither profit or no loss. The break-even level can be achieved within about 3 years based on the expected sales volume. This slide illustrates the break-even analysis using cost-revenue graph. The fixed cost of this project is 5,000 with a selling price of 10,000 per unit and a variable cost of 3,000 per unit. As shown in the graph, the break-even point occurs where the line total costs intersect the total revenue line, which is approximately 8 units sold. At this point, the break-even in sales value is at 80,000, meaning total revenue equal total cost. For this slide, explain the internal rate of return, or IRR. IRR is defined as the discount rate which the net present value of the project becomes zero. The NPV equation shown here is used to evaluate the project cash flow over time. For this project, the cash flow pattern consists of an initial investment of 50,000 at year zero, followed by cash inflow of 15,000 in year one, 18,000 in year two, and 20 in year three. The in I- the IRR is estimated using trial and error approach by evaluating the NPV at different discount rate. This slide shows the estimation of internal rate of return using trial and error method. This net present value was evaluated at several discount rates, including 5%, 10, 18, and 22%. As shown, the NPV remained negative all tested discount rate. This indicates the IRR for the project is below 5% for the 3-year evaluation period. Despite the low IRR, the project remained economically justifiable when considered together with the acceptable payback period and early break-even point.
Now I'll be explaining the budget feasibility. This slide summarizes the budget feasibility of the grinding wheel monitoring system. So the initial capital investment for 50,000 is fully allocated for development and implementations. Cost breakdowns, which is systematic allocation divided into two costs, which is direct cost and indirect cost. Direct cost is for 43,000 including materials, 50,000 equipment, 10,000 software, 12,000 and labor for 6,000. Covers all the sensors, features, data acquisition, hardware, algorithm and data processing development, and installation testing validation work. Whereas for indirect costs, for 7,000, which is including overhead, for 4,000, training and documentation for 3,000. Covers the utilities, lab admin, support and user training, manuals and technical reporting. Third, payback periods for 3.3 years. Based on the uniform annual spacing of 15,000 from the reduced downtime, fewer unexpected wheel failures, and improved process efficiency. Full recovery occurs slightly after the year 3. Next, break even, which is a deployable unit basis to 8 units. With fixed cost of 50,000, price 10,000 per unit, and variable cost for 3,000 per unit, the contribution margin is 7,000 per unit. So the break even is about 8 units. So 3 years at 3 units per year. The IRR consideration. The IRR consideration of this project is lesser than 5%. So the net per value stays negative at 5%, 10%, 18%, and 22%, implying a modest return. However, the acceptable payback, achievable break-even, and strategic real-time monitoring benefits supports the 50,000 of the overall budget are feasible and justifiable. Next, I'll be explaining the sensitivity and risk analysis and costing. This to evaluate how uncertainty in the projected cash flow influence the financial feasibility of the project. For the baseline, this project used 50,000 in initial investment in the year zero, 5-year project life, uniform annual net cash inflow for 15,000, and the salvage value for 5,000 in the year of 5. MRR 10%. Under this base, the present worth is positive, so this system is economical acceptable in the base scenario. As for the sensitive case, 10% lower benefit, the annual net cash inflow decreases from 50,000 to 13,500, revise the present worth approximately for 4,280. The effect of the payback or PW, it drops from 9,970 to 4,280, and the payback increases from 3.33 years to 3.70 years. However, the project still recovers the initial investment within the 5-year evaluation horizon and remains feasible at 10% MRR. Costing risk, it is lower than the expected downtime and scrap reduction. If personnel do not fully use the monitoring information, budget overruns from the higher installation or commissioning, sensors or hardware replacement, or the integration issues. And additionally, costs or delayed benefits cause the technical or schedule problems such as signal noise interference, data acquisition errors, or procurement delays. To mitigate the risk, we have to be careful in the cost estimation and planning bench level testing before the full deployment, prudent supply selection, reasonable contingency allocation, and structured training stage management to ensure the operators act on the monitoring outputs.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nazir Ikwan bin Ismail. My matrix number is 221310985. So I will continue this presentation on my part, which is entrepreneurship and the innovation section. Okay, so for the entrepreneurship and innovation connect the engineering solution with the real industrial needs. Next, modern manufacturing demands solutions that provide both technical improvement and economic value. This project identified a real problem in grinding operation and transformed it into a practical solution. The system focused on improving the efficiency, reliability, and also the cost effectiveness in grinding process. It also supports the competitive manufacturing environments through smarter decision making. So from the entrepreneurship and innovation, we can divide into two sections, which is innovation aspect of the project and also the value creation through innovation. For innovation aspect of the project, the system use sensor and real-time data analysis to monitor grinding wheel wear. Traditional inspection, commonly using the methods rely on manual checks and fixed maintenance schedules. Manual methods are time-consuming and also prone to inaccuracy. The proper systems enable predictive maintenance instead of reactive maintenance. This approach aligns with Industry 4.0 and smart manufacturing concept. For value creation through innovation, early detection of wear prevents the product defects and machine damage. It also can reduce unplanned downtime and also improve the production continuity. The third one is optimize grinding wheel usage extends wheel lifespan. It also can lower maintenance and replacement costs and also increase the operational efficiency. The system creates the measurable value for manufacturing company. Okay, in entrepreneurship and innovation section, I will also discuss about the market potential and also the business potential. For the market potential, grinding process are widely used in automotive and precision manufacturing industry. Many industries still rely on manual inspection for wheel wear monitoring. Manual monitoring leads to unnoticed wear and also inconsistent product quality. There is a strong demand for reliable and real-time monitoring solutions. The process system directly address this industry challenge. Next, for the target market and industry fit, our target market is for the automotive manufacturing industry. Second, it also can for the precision engineering company, metal fabrication and machining workshop, factories using high precision grinding operation, and the last one is for the both large manufacturer and small to medium enterprise. For market advantage of the system, it the first one is it affordable compared to the complex commercial monitoring system. Second, it easy to integrate with existing grinding machine. It also can minimal the modification required for installation. It's suitable for different production scale. And the last one is it high relevance with increasing automation and also digital manufacturing trends. Okay, now for the business potential. For the business potential, the system helps to reduce the operating and the maintenance costs. It also prevents the premature grinding wheel replacement. It also can minimize the material waste and also the machine damage. It can improve the overall equipment efficiency. And the last one, it supports the It supports stable and uninterrupted production. For the business model and financial strength, the system can be sold as a complete package. It comes with the include hardware, software installation, and user training. The break-even achieved with reasonable sales volume. From the model, the payback period of approximately is 2.85 years. The financially attractive for the industrial automation investment. For the strategic business value, enables data-driven maintenance planning. It can improve the long-term cost forecasting, enhance the consistency in product quality, supports the sustainable manufacturing practice, and the last one, it can strengthen the competitive advantage for the manufacturer. Okay, now we go to the conclusion part. Okay, as the conclusion for this project addressed the critical issue in grinding wheel wear monitoring. The real-time monitoring can improve the reliability and process control for the production. The system is technically feasibly and well planned. The financial analysis confirms that acceptable payback and feasibility. The project supports the innovation entrepreneurship and also the smart manufacturing. For the project impact, it can improve the grinding efficiency and productivity. It can reduce the downtime and the maintenance costs for the production. It can extend the grinding wheel wear lifespan. It can strong the market and business potential. And the last one is this system, this model or this part is practical and innovative solution for the modern manufacturing. Okay, that's all from my group. Thank you.